And let's get started on 2.2. We're simplifying radical expressions. We took a little bit of a detour in 2.1. We talked about some absolute value work that we're going to need here in the rest of this part. Now, of course, we've got to start with this because we all know this. Math is radical. So when we talk about radical expressions, how is that any different than what we've dealt with radicals in the past? Well, let's start with the radicals we've done in the past. That's just having numbers in there. So what's the square root of 121? Well, hey, we know that that's a perfect square. That's going to equal 11. The reason it equals 11 is because 121 is 11 times 11. Cube root of negative 64 now. What times itself equals 64? Well, in that one, we know that negative 4 multiplied by negative 4 multiplied by negative 4 is going to equal negative 64. So therefore, the cube root of that is negative 4. Last one, fourth root of 81. The fourth root is really the square root twice. So in this case, we're looking at what times itself times itself times itself 4 times is going to equal 81. Oops, 4, that should be a 4 there. So we got 3 times 3 times 3 times 3. Or take the square root of 81 twice. Square root of 81 is 9. Square root of 9, oh, that's 3. So this is evaluating just basic radicals. Now when we go to radical expressions, we do this. We start throwing down some fun stuff, and that's having variables underneath the radical. As soon as we got variables under the radical, different things can happen depending on what values for the x we choose. Let's start with this. X squared. Okay, if we do x squared, then this one is going to be 4. Hey, negative 2 squared is also 4. If I take the square root of those numbers now, it's going to be down to 2. So even though I started with an x of negative 2, if I squared and square root it, I get a positive 2 now. Let's do the cube. If we start with a cube, 2 cubed, hey, that's 8. Negative 2 cubed, oh, that's negative 8. Now if I do the cube root of those numbers, cube root of 8 gives me 2. I'm back to my original. Cube root of negative 8, oh, look at that, negative 2. Fourth root. If I do the fourth root, to the fourth first, that's going to be 16 and 16. Fourth root of those gets me the 2 and positive 2. Fifth root, last one there. Doing fifth, that gives me 32 and negative 32. Doing the fifth root of those, I get back to 2, back to negative 2. Signs are important here. If we're dealing with a cube, we get back to positive and negative, or to the fifth positive negative. Those are odds. If I deal with the even, it's going to be positive. Whole moral of the story, this is what we got to remember out of here. If we're taking an even root, it's got to be a positive inside. If we're taking an odd root, it could be positive or negative inside. Let's do a quick recall. If we take the root of two numbers multiplied inside a radical, I can split them up and give each of them their own radical. These here are called entire radicals. Notice that there's no coefficient in front. These here are called mixed radicals. They've got a coefficient sitting in front here, here, here. Remind you of your definitions as well. Index there in the red. That little tiny number hiding in there. Your radicand is the number underneath the radical sign. And the whole thing together is called your radical. I know, it's pretty radical, dude. All right, let's start it off. Let's arrange them here. If you have all of them with the same type of radical, all of the part A, square root, we're going to take them to an entire radical. Got to remember how to do that? Oh, yeah. Square the coefficient, take it back in. So 5 squared, 25, multiplied by 2, that's the square root of 50. Next one, 2, square that. 2 squared is 4, takes it back in the house, times 5, that gives me square root of 20. And the last one, we got 4 squared, that's 16, multiplied by the 3, all inside. 16 times 3, that gives us 48 inside the radical. So I got to order them greatest to least. 50 is bigger than 48, bigger than 20. So we're going to go in that order. So this one is 1, this one's 2, that one's 3. All right, but write down the original. The original was 5 root 2, then 4 root 3, then 2 root 5. Do exactly the same thing now when we've got the cube roots. All of them are cubed. We're going to take them inside, except instead of squaring the 5 to get 25, now we're going to cube it. So in this case, 9 cubed. Okay. And we could do that. 11 cubed, take it in. 8 cubed, we could take it in. But wait a minute. Let's look a little bit more closely at these. If we look at them, we notice that, hey, all of them have the cube root of 2 as the radical. That's all the same. So all we have to do is compare the 9, the 11, and the 8 this time around. So let's just write them in the order. Greatest, 11. So 11, cube root of 2, then 9, cube root of 2, then 8, cube root of 2. There's my order. Last one, we've got some fourth roots, we've got square roots, we've got cube roots, we've got lots happening. The way to do this one, to compare them, use your calculator, take them to a decimal. So the first one, 3/4 root of 8 is equal to, punch it into your calculator, 5.0453 ... goes on forever, it's irrational. Then we've got 4 root 2, punch that in, 5.6568 ... And 3 cube root of 5, punching that one in, 5.1299 ... Oh, now we just put them in order. We look at this. We got 1, we got 2, we got 3. So let's put those down. 4 root 2, 3 cube root 5, 3/4 root of 8. Another quick reminder for you, if we've got a radical with a quotient inside, 16 over 9, we can give them each their own radical and work from there. And that's known as the division property of radicals. Fun stuff. Let's use that piece of information. So write this now as a mixed radical. It means take it down to lowest terms. I'm going to start by giving the numerator and the denominator their own root. So cube root of -16 and the cube root of 135. Whoa, we've got a negative inside the radical. Is that okay? That's all right this time because it's a cube root. Cube root, fifth root, seventh root, odd roots with a negative inside are all right. Square roots, fourth roots, sixth roots of negative numbers, not so much. And now we need to break it down here. Cube root of a negative number. Hey, I know that that's going to be negative something right off the bat. So let's go and let's take that 16. I need to break it down. I don't remember my perfect cubes off the top of my head, so I'm going to take it and do my prime factoring. Prime numbers, 2, 3, 5, 7, those fun things. So start by dividing by the first prime number, 2. 16 divided by 2 gives me 8. Divided by 2 gives me 4. Divided by 2 gives me 2. Divided by 2 gives me 1. Work it all the way until you get to 1. And now, because we are doing a cube root, so cube root there, we're going to do in groups of 3 of the same. Well, when we do that in groups of 3, that means we've got the group of 3, which is going to be 2, and now the cube root of whatever's left inside on its lonesome, that 2. Color coordinate this for you so you can see where things are going. So those go to the outside. This lonesome one goes inside. Let's bring that back in. I know that I can take the negative out because it's a cube root. So 2 and the cube root of 2 over. Let's do 135. Do exactly the same thing. Let's break it up. 135. Doesn't divide by 2, but can it divide by 3? It sure can. And that gives us 45. That can also divide by 3, gives us 15. That divides by 3, gives us 5. We want to take it down till we get 1 using just prime numbers. And then again, group it in groups of 3 because it's a cube root. So now that comes out 3 cube root of the lonesome 5. Oops, that should have been a 3. Color coordinated again for you. Those group gets to come outside and play. The 5 has to stay inside the house lonesome. So that goes down into 3 cube root of 5. Taking it now, we want to bring it back under one radical sign. So we'll say, hey, that's negative 2/3 cube root of 2 over 5. And that one's done. Deal. That is the lowest terms mixed radical. All right, let's go the other direction. We went from an entire to a mixed. Now let's go from a mixed into an entire radical. Let's bring it all underneath that house. But be careful, listen carefully on this one. We got a little bit of an issue, a little bit of a problem to deal with. And that's right here. Specifically, right there. There's a negative sign sitting in front. We got to somehow deal with that. Okay. Well, we know from what I just said, if I'm going to take it inside, if it's a 4th root, I'm going to have to take the 3 to the 4 to bring it inside. So this is really what I'm doing. Because 4th root and 4th thing, they cancel each other off. That's how I'm going to be able to bring it in. But there's already sitting underneath there a 2 over 27. I don't get to bring that negative in. If I went negative 3 to the 4th, would I have a positive? Or would I have a negative number at that point? My answer needs to be negative. Because that's what they told me it needs to be. Okay, carrying that on. 3 to the 4th. That's 81. We saw that already today. Oh, this is the 4th root. 81 times 2 over 27. We need to take this down to lowest terms. Oh, looky here. 8 divided by 27, that goes nicely. Hiya, that divides to 3. Lucky for us. We get negative 4th root of the 3 times the 2, 6. Done. Oh, look at that. That's a nice looking entire radical. I kind of was talking about it. I want you to do the thinking now. Why can't that negative sign be taken inside the radical? You figure that out. You write it down. All right, hopefully you're still with me now here because this is where it starts getting a little bit tricky. I've been setting it up to be able to go through the real questions of this chapter. The questions here, so you can see, are for which values of the variable is each radical defined? What values of x? Oh, look at that. We got variables underneath there. That ain't looking too fun. But now we want to know what values of the variable can I use? Because remember, you can't take the square root, or 4th root, or 6th root, or 8th root. No even root of a negative number. No even root of a negative number. That ain't going to work. So let's read what it has to say there. All square numbers are greater than or equal to 0. So the expression, square root of x, has a real number only when x is greater than 0. Blah, 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 blah. What does that actually mean? That's meaning that any square number, a number times itself is positive. So therefore, we can only take the square root of a positive number. That's a restriction. Let's look at cube roots, though. A positive times a positive times a positive, hey, that's positive. A negative times a negative times a negative, hey, that's negative. I can take the cube root of anything, XER, positive or negative. The only problem is no even root of a negative number. Let's look at this question now. What values of x am I allowed to use? Well, let's start here. First of all, look, is it even an even number for an index? So the index is even. That means we're here. Whatever's underneath the radicand has to be positive. Let's write that. Radicand must be positive. That's for an even root. For an odd root, no problem. Radicand can be anything. Or XER. Okay, so this part A, the index is even. Oh, we got the problem. We're in this first one. We got to look at the radicand. Has to be positive or equal to 0. Greater than or equal to 0. We're starting there. Well, let's divide over the 27. That leaves us with x squared being greater than or equal to 0. But wait a minute. When we square something, it's always going to be positive. So even if I put a negative value in for x, I square it, it's positive, that's greater than 0. This is good to go. That's always going to be the case. Squaring any number is always going to be positive, or always going to be greater than 0. So I can say then XER. There is no restrictions on that x value because I squared it. Let's try the next one. Same thing. First of all, decide, is that index even or odd? Index is even. We got a problem. Let's look her out. Let's write down the radicand has to be greater than or equal to 0. Let's take it and divide that negative 12. Whoa, wait a minute. Inequalities, when you multiply or divide by a negative number, flip that sign. Got to remember that one. X cubed less than or equal to 0. From the work we've already done here today, we know that if it is a negative number cubed, it's going to still be negative. If it's a positive number cubed, it's still going to be positive. So if x cubed has to be less than 0, so does x have to be less than or equal to 0. There's our restriction on this one. All the x values we choose have to be less than or equal to 0 for this to work. All right. Since variables can be blah, 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 that's too much wording there. All we have to know from this part right now is this. If we square a number and then square root it, it's always going to be positive. We just saw that at the beginning of this lesson. Squaring makes it positive, and then square rooting, it's a positive number. So we cannot just say that I can't say this. I cannot say this because if I use a negative x, it's not going to equal the negative x again. Just to remind you, I jump back to where we showed that. Here, this number was not the original x. This number was not the original x. They were the absolute value of the x. Oops. With that said, let's work it through here now. We've got the square root of 45a squared. This is only going to happen when we've got square rooting or an even root and an even exponent. So 45, we can take that down. That goes down into 45 breaks up into the square root of 9, the square root of 5, and the square root of a squared. Square root of 9, hey, that's a perfect square. That goes to 3. Square root of 5, stays the square root of 5. Square root of a squared. Oh yeah, we know that it has to be the positive value of a. Absolute value of a. Oh, I'm so confused. Well, good thing, because we got a lady who wants to re-explain therefore a for you.
Part A. For which values of the variable is the square root of 75a squared defined? Simplify if possible. I know that I can't take the square root of a negative number, so 75a squared cannot be negative. Since 75 is a positive number, a squared must be greater than or equal to 0. Whenever I square a number, the result is 0 or positive. So a squared will always be greater than or equal to 0, and a can be any real number. So the radical is defined for any value of a that is a real number. To simplify the radical, I'll start by looking for factors of 75 that are perfect squares. If I think about the division facts for 75, 75 divided by 1 equals 75. 75 divided by 3 equals 25. 75 divided by 5 equals 15. So, the factors of 75 are 1, 3, 5, 15, 25, and 75. 25 is a perfect square, so I'll write the square root of 75a squared as the square root of 25 times 3 times a squared. Now I'll rewrite the radical using the multiplication property of radicals, which gives me the square root of 25 times the square root of 3 times the square root of a squared. The square root of 25 is 5. The square root of 3 can't be simplified any further. The square root of a squared is the absolute value of a. So, the square root of 75a squared equals 5 times the square root of 3 times the absolute value of a. Part
Okay, so for that part A, it also asks us to say, when is the radical defined? Well, this radical is going to be defined wherever it's positive. Hey, a squared makes it positive, so this one is a element of reals. Let's look at the second one now. What do we have for our radical being defined? Again, negative 27b to the 9 has to be greater than or equal to 0. Divide over that negative 27. Whenever you divide by a negative number, you got to flip that sign. So, we're saying here that b to the 9, which is an odd exponent, has to be less than or it has to be negative. Well, then that means that our b value has to be less than or equal to 0. And let's work it through now. So we've got negative 27. Hey, that can break down. We've got square roots here. So that breaks into the largest perfect square is 9 times negative 3 times b to the 9. Ooh, that can go down into b to the 8 times a b to the 1. Now I can take my square root of 9, square root of 9. Then we've got also the square root of b to the 8. And then we've got the square root of the negative 3 and the b that I can't really do much about. 8 is a perfect square. 9 is a perfect square. The square root of 9 is 3. The square root of b to the 8 is b to the 4. Do I need to put absolute values around that? No, because b to the 4 is always going to be positive. The only time that I'd have to make it absolute value is that said b to the 3 on the outside. I can't bring the negative out. It's a square root. I get left with negative 3b. All right, starting with where is it defined? Radicand has to be greater than or equal to 0. It's an even radical, even index. So therefore, I have to look at the restrictions. So that means z is greater than or equal to 0. Good, got that part done. Now we got to simplify it. Ooh, 7z, fourth root. Can't go down any further. It is already simplified. That's as far as that one can go. Wow, I like those ones. Last one, cube root. As soon as there's a cube root, there's no restrictions on the variable. Y-E-R. Oh, love that. Let's work through, though, the rest of it. Okay, cube root, 24. So I need to break it into perfect cubes, or if you can't remember perfect cubes, great. Let's do our prime factorization. 24, divide by 2 gives me 12, divide by 2 gives me 6, divide by 2 gives me 3. Oh, there we go. I'm able to say now that the cube root of 24 is 2 cube root of 3, because that was a group of 3. So we got 2 cube root of 3. I'm going to do a little bit of the same thing there with the y. Y to the 5 is y times y times y times y times y. Again, cube root, groups of 3 that are the same. That can come out. So these can come out as a y. These, they don't have a group of 3. That's y squared staying on the inside. The final answer is going to be 2y cube root of 3y squared. Do I need to use absolute values in this one? No. There was no restriction on the variables. Only has to be done for evens. All right, pretty intense stuff there. Make sure that you go through these, think about it, try to read their examples, bring it together, and then ask me questions in class. We'll see you in class.